This is a very simple model, but at this stage, you are already all set to create your own models. But let's see how to create somewhat complex model. A very simple plant control model that's using some of the inbuilt blocks instead of building anything from scratch. So let's see how that can be done. It's a pretty common application for Simulink. So I will just shift drag this block. Shift drag meaning holding shift on the keyboard and then dragging it with my mouse so that I can add other blocks. Now, if I don't want this block in my simulation, I can simply delete it. But if I'm not sure, I can also comment it out so that I can bring it into my simulation later if I need it. So it's like commenting out lines of code in MATLAB. And you can see it's a similar indicator, a percentage sign. So when I'm running my simulations or generating code later on, this block will be ignored by Simulink altogether. It's just the nature of building up models. Everything is not going to be perfect. You're going to want to try new things. So, oh, let me try something else. But I might want to go back to this. So let me drag this off to the side, comment it out, and maybe I'll refer back to it later. So let me bring in some additional blocks here. I can bring in a plant model, which is essentially a transfer function. It's a first order transfer function with the denominator coefficients just 1 and 1. Just to make it look slightly interesting, let me change it to something like 156. That makes this a second order transfer function slightly interesting. I can simply bring it and join it to the scope block. And if I'm still interested to monitor the signal, which I am, and change this to plant. And you see this line is intersecting with the plant I just created. So I can simply click that signal and auto route it. So that will take care of not intersecting with the blocks. Okay, so now for the plant model, let's bring a PID controller and switch it for it. It's available with the continuous library. Let's bring it and plug it in between the source and the plant. You can see how the signal connections are pretty straightforward. Simulink is smart enough to understand that if it is aligned with the right port, so you might want a pond connection and it would just create a connection for you. Now, one thing I would do with the signal that goes from the sine wave to the scope, I would actually drag it below. You are free to move the signals around, but you can also let Simulink auto-route it according to the algorithm for the best optimization. You can run the simulation at this point and just see how it looks like. And also, the other thing is we are using sine wave, and it's tough to really track what's going on. Probably a step input is better. Yeah, so let me delete this sine wave and bring in a step block from source library. The default value is 1, and so I will leave the step time as 1 and just join it back to my model. Let's run the simulation now. It's still open loop control. Yeah, okay, so we want to have a closed loop system instead. So I bring a sum block here with the intention of you're going to take the error. You're going to do a difference here. So I just look at the difference between the input and the output. And so that the control signal is appropriately sent from the controller to the plant. So I hit that and change it to the minus. I would like to just drag it here, but since there are multiple ports, it would just not join it because it doesn't know which port to join it to. but it's not that difficult. Just add and move to the blocks out a little bit if you like. Uh, and then take the signal back and connect it to the plant. Bring that signal down here as well. Now this looks how we need. Yeah, and see how the controller behaves now.